co-founder of Knowledge Networks. I'm very, very pleased to give you this, this presentation about a topic that's been really, really close to our heart. Before we start, fun fact, and it's something that might be interesting for you. My very first job / internship in Canada was paid by my tax. My academic supervisor was Professor Witte. Our contact was Jesse, who's sadly not here today. I ran into Jesse 2 years later. We had to talk about entrepreneurship. He gave me a speech about entrepreneurship, and he convinced me that I had the it. A couple of years later, look where we are now. So your money is not going to waste. The job that you're doing is actually making an impact. Give it to you.
So welcome back, everyone. Thanks a lot for the invitation. We couldn't agree who gives the talk, so we're going to split the material between us both. Both of us also have a side job besides working in our own startup. I'm a professor at Concordia University, working on artificial intelligence, semantic technologies, and Bahar can tell you later what she is doing. So the topic that we want to explain today is what you can do with a large amount of information. That's the proverbial information overload. You all know that nowadays more information is being generated in just 1 minute than a human can possibly process in a lifetime. And even when you stay within one organization, you have the problem that you have a large amount of existing knowledge stored in documents, emails, databases, and so on. But in many organizations, this is not managed in an automatic way. It's a typical problem for knowledge workers that when they have to solve a task, look at past solutions, come up with something new, they have to go through all of these documents manually. And very often the information is there, but it's just very hard for them to find it. And it takes a lot of time. So the idea is that AI or some specific AI techniques that we are going to show you today can help you with this. And some of those are very easy and very simple to deploy. So the goal for this talk is to introduce you to 3 basic AI techniques. It's a bit of a historical progression. I'll start explaining what's called text mining and move over to knowledge bases, knowledge graphs. And then Bahar will take over and talk about intelligent agents, chatbots, and so on, which are currently the cutting edge. So for each of those, after the talk, you should know what they are doing. Maybe you have an idea what they can do for you within your organization, and we'll give you some specific pointers on how to approach deploying this kind of technology. That's the goal for this talk. So let's say you have an organization, doesn't matter if it's governmental, academic, industry. Very likely you have a large amount of documents, memos, user guides, emails, design documents, contracts, whatever there is, plus possibly external information, how to approach a certain problem, process descriptions, and so on. So let's assume that at the very least you have them stored in some kind of search database. This is established technology, search engines that you can install locally. Just like you do a Google search, you can then do a search on your own documents for a keyword. And this will at least help you locate documents with certain information. So let's say you have indexed all of your documents, and now you want to find information for a specific person, like Steve Jobs. You can just type this into your search engine, just like put it into Google. And the search engine will pull up all the documents where this term appears. Instead of a person, you could imagine some kind of technical information, some organization, contract information, whatever you need for your specific task. So this is all fine and good, but this search paradigm breaks down as soon as you have a slightly different problem. Let's say you have to find within your documents all persons that are mentioned, or all organizations, all patents, all inventions, everything for a specific category. Then you can no longer do a simple search. You cannot just type in person and expect to come all different person names to come out. Same for finding technical information, and so on. So instead, what you need is what's known in AI as information extraction, which is one specific technique that falls into text mining. As text mining suggests, it's a technique where you have natural language documents, unstructured text, and you want to extract information out of them. So how would you do this? Because you are working with natural language documents, you need what's called natural language processing. This is a subfield of artificial intelligence. And there are various techniques for analyzing documents in natural languages like English, French, German, and so on. So roughly, you build what's called an analysis pipeline. You throw in your natural language documents. The pipeline looks for certain information in there and outputs it in some structured form. So we can now move from that first approach where a human is doing all the search manually through the documents by giving the human this AI text analysis engine, which will look for certain information, and then the human can focus on the more interesting, the more creative tasks with the results from this analysis. So this is the first step of improvement. How do you make that happen? Well, this is a standard technique in artificial intelligence. It's very mature. It has been around for at least 20 years now. You can find either existing tools that you can use directly. I'll mention them briefly again a bit later. And there are also a multitude of web service solutions where you just send some text that you want analyzed to an external web service, and the service will extract certain information and send you the results back. The example here, in one of the tools, you load your text and then it can highlight, in this case, things like dates, persons, locations, organizations, emails, and so on. And you can imagine that you adapt this to the specific information that you want extracted in your organization. So this is what was a bit earlier already mentioned as named entity recognition. It's a specific kind of information extraction. You look for entities like persons, organizations, inventions, patents, and possibly also the relations between them. Which person worked for what organization, and so on. So the way this is implemented is that somebody has to understand what you are looking for and then build an analysis pipeline for this specific case. So something like shown on the upper right, there is usually a sequence of steps that you go through, where one step output is the next step's input. And in each of these steps, you do various filtering, analysis, extraction operations. Many of those are readily available. This is not really a research problem. For a large number of tasks, you can simply take existing solutions, possibly with some adaptations for your specific domain. So what these tools will then do is for you look at your texts, and obviously they can do this very fast, much faster than humans, and give you the results that they extracted in some structured form. So I mentioned you can either use existing open source tools, but there are also a lot of companies that offer this as a kind of service where you would sign up and pay for it. A very well-known one that has been around for a long time is the service by Thomson Reuters, OpenCali, where you can send text and it will extract, again, information like organizations, person, and so on, and give you the results back. So you can use this without even developing any tools in-house. As an example, a system that has been around for quite some time is a news analysis system that was developed in the European Union by a research center in Europe. Primarily developed for members of the European Parliament that want to be informed about what's going on in all the member states. And the system analyzes each day roughly 300,000 news articles and extracts information from them in up to 70 languages. So you can imagine that a member of the parliament cannot possibly have the time to look at newspaper reports in different languages, thousands of articles per day. So a system like this will do all of this work and then structure it in various forms. For example, detect all the persons that were mentioned there, which is not an easy task when you go into multiple languages. As you can see here, Angela Merkel has very different ways of being written in newspaper articles, depending on which language you talk about. And the system additionally extracts things like what did she say according to news article, or what was said about her, and what were the people mentioned in connection with her, and so on. So primarily it was developed for the member of the parliament, but everybody can use this for news analysis. So you can imagine a similar system is also very interesting in a business setting. You want to know from all the tech news what's going on, what are the competitors announcing, what is being said about their companies, what are other people saying about you, and so on. This is a very similar kind of problem. Another technique that has been around for quite some time and commercially adopted is what's called sentiment analysis or opinion mining. And this was one of the earliest adopted techniques because it's commercially very interesting. Think about what you do when you want to buy a new product or use a service from a company. What's the first thing you do? You check online what is being said about that product, about that company. So for companies, it's very important to know what is being said about them, about their services, about their products. But nobody has possibly the time to look at all the social media, product reviews on websites, posts on Twitter, and so on. Still, they have to be informed about what's going on. When somebody mentions a new product or service in a bad way, this can be very damaging very fast. So companies want to know about that. So there are tools that fall into this category for opinion mining that scan typical news feeds, Facebook, Twitter, postings on Amazon, and so on, and will analyze at the very least the sentiment. Was there something positive, neutral, or negative said about that product or service? That's sort of the simplest analysis you can do, and others break this down into more detail about what specific aspect of a service or product was something good or bad mentioned. So again, this is not really something where you would have to put research into. This is out there. Amazon, for example, as part of their web services, has a number of tools called Amazon Comprehend, and one of them is sentiment analysis. So you can put in something like a product review, in this example, something writing about shoes they bought online, and then it will tell you with what confidence the result is positive, neutral, or negative. One aspect that wasn't mentioned so often today is that AI can go wrong. This is all based on statistics, and the AI is going to make mistakes. It's going to be accurate 80–90% of the time. So this example came in the news a couple of weeks ago, where a company, Westjet, had this automatic sentiment analysis within a chatbot, which we'll cover later. And one customer was overexcited how terrific the service was, and she had all these superlatives. And the answer of the chatbot was, oh, this is very concerning. Have you tried contacting a suicide prevention hotline? So obviously, that sentiment was completely misclassified. Bottom line is, AI is going to make mistakes, and you have to be prepared for these mistakes. Sometimes they are quite entertaining. Another case that was in the news just a few weeks ago, some of you might have heard that, Amazon tried to build a text analysis engine for resumes, for hiring people, so that you can feed in a few thousands of resumes and it will pick you the top N to look at. So they trained the system on all the people that were hired in the company. And then when they examined the system, what they figured out is that implicitly the system learned that it must be better to hire males because the majority of the employees in this tech company were males. So it got this implicit bias just from the data. So this also goes to the aspect that was mentioned earlier. You have to be really careful about what data you fit in. It's called artificial intelligence, but it's really not intelligent. It just learns from what is out there. So bottom line was that they had to scrap this entire system because this was obviously not what they had in mind when they built this. So for this first part, the message is when you have documents and you don't have any kind of automatic analysis extraction, it's really not difficult to get started with this. There are lots of open source tools and services out there that you can just deploy. I found very often the problem is not that the tools are not available. When I talk to people from businesses, they don't just know that this is available and that they can use it. I often hear, we didn't know that it's possible. And very often it just comes down to doing a small experiment. Like we heard today in the first talk, do something agile. If you have a smart student, you can build your system over the weekend using these tools. And then you can go on and see what you want to do next. You know, so you don't have to plan even a 3-month research project for this. So moving a bit further in terms of technology, the second thing I want to explain is the idea of a knowledge graph and connected with it a knowledge base. And this is another typical problem organizations have, because all the information that is out there in an organization is very compartmentalized. You have databases from a certain system, you have your documents, your spreadsheets, you have maybe source code or other data sets, but they're not interconnected in any meaningful form. And very often you can make conclusions by connecting these different pieces of information. This is something humans can do, but it's very time consuming and it's often not done. So you're missing out on a huge potential on the information because you're not automatically cross-referencing and connecting your knowledge. And the same, in the same category falls the missed opportunity of connecting to a large number of knowledge that is now out there in form of so-called knowledge bases. These are databases primarily for artificial intelligence purposes on the web that store a large amount of information about pretty much everything. I'll show you some examples in a minute. So the point is that you can enrich the information that you have internally with information that comes from the internet and is continuously updated. Information about technologies, about products, about services, about people. And use this to gain even more insights. So the next evolution in our architecture is that now instead of dealing with these documents directly, you have this intelligent analysis pipeline behind it, the NLP from the first part, and now in the second part, something that connects this with other knowledge resources. You probably have all heard about the concept of knowledge graph in the context of maybe Facebook graph search or Google's knowledge graph and so on. So just to give you a simple idea what is meant with a knowledge graph, the core idea is that you represent knowledge, information in form of a graph in the mathematical sense, where you have nodes and the nodes are connected with edges. So for example, there is a node about a person, and the person has certain attributes like an email, belongs to an organization, works on a problem, and so on. And all of these connections are shown in form of a graph. That's basically it. You represent what you want to model in this graph structure. So this comes out of web technology originally, not really out of artificial intelligence. It was motivated by the idea that so much information is out there on the web. So many services are there, booking flights, scheduling appointments, but it's all meant for humans. It's very difficult for a computer to make use of this information on the web. So there was a large initiative that started almost 20 years ago called Semantic Web, which basically meant a web that also computers could use. In parallel, we had this big evolution with social networks. So now we are sort of in the upper quadrant where these two technologies merge, and we get these intelligent agents that have both social behavior and AI behavior. In case you wonder why is this suddenly connected to web technologies, it's when you look at these graphs, it's not just nodes with a label like a person name or an organization name. Each of those are actually a URI. You can see it on the bottom for some of these. So when you want to know who or what the Mona Lisa is, there is a URI that you can look up online in a database, which is machine readable, and you have all kinds of information. Who created it, where it is currently located, and so on. this is not meant, oh, man. This is my personal AI telling me I should move on. So, so you have all seen this because this has become widely adapted by tech companies. You probably have noticed a couple of years ago when you used Google search, it no longer just gives you search results. In many cases, it already gives you answers in form of these fact boxes. Like here, I ask who is Steve Jobs, and it will give me this fact box about where he was born, where he died, and other information. And this is exactly this kind of graph information that I just showed you. Steve Jobs, born in location, died in location, and so on. So Google actually used various databases that are available on the web that you can use as well. They also bought a startup that created databases and that became part of their own knowledge graph. But there are many knowledge bases out there that you can use freely. So the point is you can now connect your information to this information on the web. And this is interesting because now you can enrich your documents. Now, if your texts talk about a specific technology, you can link them to information on the web and get more information about that technology. The way this works is, again, there is a new problem that you're facing. It's no longer enough to detect certain terms, like a person name or a technology name, like this an example, a tree. You also have to be able to disambiguate it, because the same term can stand for different things. A tree can stand for the tree that's standing outside, or the data structure. Or if you find the word Paris in a text, it could be Paris, Texas, it could be Paris in France, or it could be Paris Hilton. So it's important you link to the right entity, to the right database, otherwise your system is going to make completely irrelevant conclusions. And sometimes you see this happen. Again, earlier this year, somebody posted this. Somebody asked Siri about how do you call a group of moose? Is it a flock or what is it? And she said, it's Jared Padalecki. Why? Because he has this nickname, Jared Moose Padalecki, and based on a bad entity linking, it concluded that this must be the best answer for this question. So there is, the message is there is a large amount of data out there for these agents to use. Yeah, when Google or Alexa or Siri give you answers about movies, restaurants, people and so on, it's not like somebody was sitting there and typing this all in. This is all available on databases on the web, geographic databases, government databases and so on, which are specifically designed for these intelligent assistants to work with. And this is how all of these assistants are built nowadays. So the additional technology you need is some way to link your documents with the information that's on the web, and then you can pull in external information to enrich the information you have in your organization. And then you can answer questions that's not possible to answer just with the documents alone. Let's say you want to know what projects did we do that involve machine learning. Well, machine learning has many sub-techniques, as we've seen today. If the documents mention deep learning or Bayesian networks or something else, if you just search for machine learning, these documents are never going to be found. But these databases link all of these information together and then can give you the information that you're looking for. And one more thing they enable is so-called reasoning. Often you cannot find information directly, you have to reason about it. So here is an older screenshot I luckily still had, where the question was, what's the time now at Concordia University? And this is not an information you can look up in a database. Yeah, it's not like somebody is every second updating the time at Concordia. You have to reason about where is Concordia physically located? What is the time zone in this place? Is the time zone that's something that's changing? So this system would display step by step how it came to the conclusion on how it arrived at the current time. If you look for this now, you're not going to find it because True Knowledge, first it was renamed to Evie, and then this was a startup in Cambridge, and then it was bought by Amazon and is now part of Alexa, of their intelligent agent. And Bahar and I have also been working on an intelligent agent specifically for scientists. The scientists have the problem that a lot of research is being published every day, and way more than a human scientist in academia or industry can possibly read manually. So there are easily tens of thousands of articles even for a specific narrow field coming out. So instead of overwhelming a human with all of this information, we designed an assistant that would go through these research articles and extract specific information, like what was claimed in this article as new or as improved, and linking it with specific technologies, and thereby helping humans to really focus on the creative task that was mentioned earlier. So I'm going to give over to Bahar, but the second take-home message is you can get even more out of your information if you connect different parts that you have in your organization, spreadsheets, databases, documents, and not just connect them with each other, but also with externally available information. And with that, I would like to invite Bahar to talk about the really exciting part, the intelligent agents.
Thank you. Which one do you- Right, so let's revisit our architecture. So far we looked at the trove of information that you have, NLP pipelines that can extract information, knowledge bases that can connect the information. But if you look at the architecture, the previous one, version 3, we had the person interacting with the knowledge base. Now we talked about graphs, and we know that we can query graphs and you can query information, which is not exactly user-friendly, right? So we thought, how about we introduce a new entity into this architecture, a personal intelligent agent that has access to the rich information inside a knowledge base and can just converse with a person. Cue in conversational agents. Intelligent conversational agents, or as you might know them as chatterbots or chatbots, are just basically software programs, with the exception that they can understand and respond to end users using a natural language, like English, French, hence the conversation. There are different kinds of chatbots. They're not all made the same because they are built for different purposes. If you look at the framework on the right side, you can divide them into two sections. First, you want to look at the chatbots that are generic. These are basically companion AIs that can converse with a person. But some of them are built for a specific purpose. For example, you have chatbots which are for troubleshooting at IT desk, for example. And you also have two kinds of chatbots in the way they respond to a user. We have retrieval-based chatbots, which their job is to go through a large amount of information, find the actual response to your question, and return it to you. And you also have generative-based. These are state-of-the-art chatbots that will create your response from scratch every time based on the context where the question is posed. And they're obviously harder to implement. But regardless of how sophisticated they are or what technology is used on the back end, most of these chatbots are more or less based on the same architecture. There is always some kind of a front end. It can be a web-based, it can be a pop-up on the bottom of your web page, it can be a mobile app, it can be integrated into your Facebook Messenger. There's always some kind of an NLP component involved. Involved in the architecture. That is your first point of contact, which understands the question, and at the end tries to generate the response in a natural language. The NLP component has access to that knowledge base. It can come from your internal knowledge base at the organization. It can connect to the web, bringing in more information and integrate basically more data into the response. And some of them optionally, they also have databases where they can store the interaction history with the user. So let's say in the context of troubleshooting at a tech company, the bot already knows what solutions they've already tried or what context the person comes from. Now, the chatbots, I know they're really hyped in the past few years, but the concept goes way back to the 1950s and 60s. So Alan Turing, a very famous computer scientist, he theorized that a truly intelligent machine would be indistinguishable from a human. So if you have a very, very intelligent machine and you hide it from the view of a human and they try to talk to each other, if it's really, really intelligent, the person wouldn't know that he's talking to a machine. And when there's a theory, scientists get to work. So in the 1966, scientists at MIT, they created ELIZA. ELIZA was supposed to be a a psychotherapist bot. It was trying to simulate a conversation where it encourages a person to talk about their emotional problems. It was very, very basic, not much AI into it, and it would just try to keep the conversation flowing, maybe respond based on some trigger words that if you say, well, it's exam times, I'm really stressed, and it finds the stress word and it says, well, maybe you need to sleep more or you just relax. After that, scientists at Stanford came up with their own bot. Now, this bot was supposed to be the patient, a schizophrenic patient that can hold up a conversation but can get increasingly paranoid, but the conversation still makes sense. And they put Eliza and Perry together, and there's a 3-4 page long conversation between the bots. It's online, it's hilarious, you should read it. But the very first bot that had AI and could keep up with the conversation, put some humor to it, and just basically be entertaining was Alice, who was built by one person, one computer scientist. And as a fun fact, Alice was the inspiration behind the movie Her, if you watched it. In the early 2000s, tech companies joined this movement. They also wanted to come up with their bots, well, for a different purpose, not for much for companionship. The first one to go to the market was IBM, because IBM had this really huge infrastructure for processing information. They had access to data centers. So what they did is that they gathered as much information as they could from dictionaries, encyclopedias, and everything. They processed them. They created huge knowledge bases, and they created Watson as a new project. So Watson was basically a question answering system. You could pose a natural language question to it, and it could go through that knowledge, possibly go to an external database, integrate knowledge, and answer to you. And famously, they actually registered Watson as a participant in a game show called Jeopardy, and it beat the humans, actually. Not beat them physically, but beat them at performance. Yeah. Later on, Apple and Google came up with their own personal assistant. These are voice-enabled personal assistants that were integrated into their hardware. And they could automate some tasks that you can do on a mobile phone, or you could play different, let's say, a personalized playlist of videos and music on your devices or your other connected devices at home. Amazon, as René said, they also acquired some startups that made their Echo and other devices that they had very, very intelligent. They also moved to this area. Microsoft later joined because Microsoft, but here's something very interesting about Microsoft. So they created a chatbot called Tay, and they released it on Twitter. Tay used Twitter to tweet at people or reply to their tweets. They released it online, which created a really big buzz because it was the first of its kind online. But there was a design flaw. It was a closed feedback loop. So the bot was learning from the conversations. And people of internet, being people of internet, in less than 16 hours, they taught the bot to tweet racist, sexist, and misogynistic tweets online that Microsoft had to shut down the project middle of the night, and they publicly apologized for it. Here's another story of how AI can go wrong, but only to replace it with Zoe, who is another chatbot and still living on Twitter, but it doesn't tweet at real time, damage control, but it can generate content by adopting the style of a teenager who's trying to tweet. So it creates content, it uses internet slang, and so on. So I know chatbot seems like hype, and I talked about the history, but the landscape of chatbots and people who are involved in this business is very, very crowded. In the middle of this picture, you have platforms like Facebook Messenger, Line, Skype, and others who open their APIs to people who want to make a chatbot. So you don't have to develop from scratch because those platforms are established, people have trust in them, they're already integrated into everyone's lives. Around that, you have the community of companies that created tools that you can use to create a chatbot. Now, if you look at the horizontal and the vertical axes, you have marketing to support. So on the marketing side, these are tools that can be used to create a chatbot for marketing purposes. All the way to the support, these are chatbots that are made for support of existing customers, for example, of the businesses. And you also have on the vertical axis from managed to self-service. Managed, it means that these tools will support you in creating a chatbot, but they don't do the actual development. They outsource it to other companies. On the self-service side, they have the technology. In the inner circle, you have the providers. And these providers are basically people who would use those tools and they would provide you with kind of a solution. Now they can be managed services or they can just develop for you. And in the inner circle, you have all the brands that have already adopted this technology. And you can see this is a very, very crowded space. Some notable examples here is that, for example, Bosch has a chatbot that you can converse to if you have to troubleshoot one of your kitchen appliances. Maroon 5, the band, they have a chatbot that can just go to their fans and talk to them, listen what they think about their latest music, give them personalized news updates. We have brands like H&M or Sephora that try to market their products based on the characteristics of the market or what they want at the moment. And I think there was a Hyatt Hotel has a chatbot that welcomes you to your room, can talk to you. It's basically a hospitality chatbot. So moving on from this landscape, now you can see, or at least guess from that crowded space, that the global market for chatbots is huge. It's expected to create $1 to $3 billion in the next 5 to 7 years. It is expected to grow by 25 to 40%, and chatbots, by Gartner and by Business Insider, they're deemed to be one of the top 5 emerging technologies nowadays. Now, when you think about chatbots for your business, think about how they can derive or they can bring benefits to you across the value chain. In sales and marketing, I just talked about some examples. Look at HR and operations. Just figure out how your employees are doing, what they're tweeting. Probably you don't want to follow them on social media, but have chatbots that help with onboarding of your new hires. Streamline your operations, things that can be intelligently automated in your business. You also can have chatbots across service and payment. For example, if you're a credit company, if you're a bank. And think about retention and growth. Retention of your customers, retention of your employees, and how you can go and not poach, but maybe find the right talent for your company. What's the take-home message? So remember this framework. If you want to go for something that's closed domain, it means the types of questions that a chatbot can answer are quite limited. And if you go for a retrieval-based chatbot, which means the questions and answers are sort of guessed up front, the types of questions that can come in and the corresponding kinds of answers that we can get, the chatbot can give to the user, you're looking at a rule-based chatbot, which is really, really easy to develop. You can probably do it with someone over the weekend. The more you go towards the generative side, you're going to need deep learning, a lot of advanced AI, a lot of advanced text mining practices. But they are more natural-like, they're more human-like conversations, but also more difficult to develop. But the question before you even adopt the technology is that you have to write down the business case. You have to specify the use case. Why do you need the chatbot? What do you expect from this chatbot to contribute to your business? You have to determine the KPIs and evaluate the chatbot. You can't just release it. You remember what happened with Tay? You can't just have a chatbot that's like the forefront of your business and just release it on the internet and see how it's doing. So you have to constantly evaluate if the chatbot is actually contributing to your business and what specific metrics are you using for evaluating the chatbot. And AI can go wrong. You have to re-envision your entire risk management. You have to figure out what are the safeguards that you can put in place for stopping your bot when it goes rogue, right? You can select a vendor from that entire landscape that I showed you. There are lots of startups, including some really good ones in Montreal that can do that for you. Or you can go with any open source tools and libraries and create your chatbot in-house. And like adopting a pet, hiring a new employee, bots need maintenance. You can't just make a bot and release it. You have to constantly be able to adopt an agile approach. You have to figure out if your bot is doing well. If the requirements change, if more data is available for your AI, you have to be able to, in an agile fashion, you have to be update your chatbot. Now, with all the information that we threw at you, now our question from you is that, how are you going to leverage AI in your business? That's it. Thank you. Too much science for afternoon? Oh. Was it too good or too complicated? Can go either way.
My question is to the audience. Does anybody else feel slightly anxious and embarrassed speaking to a mobile phone to ask a question in the street? Interesting.
Well, it depends if you're asking your bank balance or a weird rash or what's the state of the art in chatbots. Questions? Yeah.
You said you also have a business that you've developed. What is that all about? Can you talk about it?
Yeah.
Right. So the product that we developed is specifically targeted at researchers and scientists and people who have to deal with a lot of academic information. So it can be any journalist, it can be a technician, it can be a graduate student who has to go and read a lot of papers. Right? And those papers are difficult to read. They're 40 pages long at times. So we created an intelligent agent that will go out, crawl, bring in, process all these papers, put them into a knowledge base, and then you can ask that entity to do tasks on your behalf. For example, you can ask Noli, our agent, to create a literature review for you based on a set of topics. Or you can give your manuscript to Noli and it will do proofreading for you and can tell you what's the reading level of your text, if there are any arguments in them, and so on.
Is this a non-profit or you pay for your services or how does it work?
So it's on a freemium model. So currently it's free for everyone. You can sign up, you can use it. But we plan to integrate some sort of paid services later on into a different layer. Sure, yes. If you go to, do we have it? Do we have the?
Yeah.
Nope. Well, let me see if I have the, did you put the URI?
At the end of, I briefly mentioned it at the end of the knowledge graph sections.
It's there. No AI.
And
okay.
we can give you a small card with the URL on it. So you can try it out. It's in beta at the moment.
What would be the average cost for a small, medium company to develop
To develop something like Noli? 6 years of PhD? In our case. So believe it or not, Noli was built entirely on open source software. So we know a lot of open source tools, frameworks, APIs that we put together to create Noli, plus years and years of experience in text mining and AI from Professor Witte's side, of course. But really the cost for having this up and running is the cost of the cloud that we have to pay for so that other users can actually use it. It's not really the tools that we did, well, obviously we didn't outsource it, we developed it ourselves. And yeah, this is a testament that you can build very sophisticated tools based on open source software out there.
I'm really interested in this solution. I want to know if it just puts the similarity in terms of words, or does it refer to, for example, references, which topic is being referenced the most? For me, that's very interesting. When I look at 10 research papers and I find one really standing out, and I want one of my team members to know more about this, it's like, this is popping, we gotta see it, you know? So does that get like a preference in the engine? Like, I would love to see something.
Yeah, you have to be careful to ask Bahar. She did her PhD on that, and she's not going to stop talking for the next. it's a good question, but I think maybe we talk about this later.
Yeah.
Because
quick question, how difficult would it be, I see it's towards scientific tasks, but how difficult would it be to leverage to other industries, such as law, for example, or technology, IT, for instance, this specific product that you developed?
so the general approach of humans collaboratively working with an agent is sort of transferable into different industries, but the actual training that was mentioned a couple of times would have to be redone for a different domain. The reason we picked this domain is because first, we are both scientists by training, and second, there isn't really anybody doing AI for scientists. It's a big problem for both R&D and academics. You have these thousands and thousands of scientific work coming in daily, and nobody can keep up with it. And so there is a risk that you miss important information, redo work that was already done. So there is sort of a motivation to have this supported by AI as well. Whereas for a lot of other domains, there are many startups working on AI for the legal domain, for technical troubleshooting, and so on. So this is a more crowded market.
Or if I may add something to this answer, when you look at a project like Nolly AI, roughly we can separate it in two parts. All the language understanding part and everything else, which is resource management, the interactions with the end user, and so on. So on this part where you have the resource management and all the UX is transferable to any domain. You can change Nolly to a different logo and have it as a different system. It's only the language part that has to be retrained. That's it. The process is the same, the input data is going to be. Depends on the size of the data and depends how the granularity of the information you're looking for.
And how much money he has.
And how much money, of course. Eric?
I have two questions. One is, what are the typical challenges in the first part in terms of that implementation? Say, okay, I have this business and I want to use it. What are the main problems that I'm going to face if I try to build these graph charts and knowledge around this?
So I think the first problem that I encounter is not the technical problem, is to get two people together, one that understands the business and one that understands technology, and have them work together collaboratively and try to understand each other. What I mentioned earlier, the business people has to understand what is actually possible, and the technical person has to understand what problem they are trying to solve. So I see that finding a good match of people that can communicate and interact and come up with something new, because in this domain, very often you do something for the very first time, is the first thing you have to have. You have to find two people that can work together. So a lot of the technology is already there in forms of libraries, open source tools. Yes, sometimes you have to do new research, an actual research project, when you want to push what's possible. But I found for a vast majority of business cases, there is so much already possible, but people don't know how to adapt it.
The other one is more for the chatbots, but maybe for both.
It's in terms of maybe security. The moment we discovered that fire was good for cooking, someone used it to burn them, hurt someone. So in this case with chatbots, one of you mentioned to protect the backstops or protections when things go wrong. Now, in that example, the chatbot itself went wrong, if you will. It wasn't that intentional. But what do we need to be concerned or protect when there's intentional, an organization or individual wants to intentionally use that technology to do damage, to take, what can go wrong?
Yeah. So it's a more general question, and there's actually lately has been a lot of proof of concepts and research into something that we call adversarial attacks. This is how you find how to corrupt an AI model, and it's much easier than we think. For example, there's an actually really nice example about that. Autonomous cars, right? They use image processing to detect like the road signals, right? And for example, there was a stop sign. So the AI knows how to detect the stop sign and it knows what it means. And somebody figured that if you put a white sticker at this size next to one of the letters, it changes the AI model and it thinks it's just a speed limit. And it doesn't stop at the cross section, right? So I think the risk is from two different parts. One is that AI models, they can be attacked scientifically, mathematically, if you know how. So there is research on that, and there is research on the way the chatbot behaves, which is more on the behavioral side. And it's really it comes down to the design, that you understand when your AI is making decisions that don't make sense, like not stopping at the stop sign, or when your chatbot is just being rude to a person or doesn't respond in time, so then it's perceived as useless, right?
Maybe briefly adding to it, it was the question of ethics in AI was mentioned earlier, and also that the legal frameworks are going to catch up with this over the next couple of years. So Europe, for example, is working on legislation where AIs have to be able to explain their reasoning. So it's no longer going to be legal that an AI just denies your credit card application, and the bank cannot say, our AI told you so, it thinks you're not good enough. They will have to provide a chain of reasoning for their decisions. Okay. But this is that's going to happen in the next couple of years. You have seen this with how long it took for data protection laws to be updated 15 years after the web. So this will come, but it's in the very early stages at the moment.
Yeah?
So, just a quick question. The example that you gave, in aircraft electronics, what they've done is to essentially have two different processes developed completely by different teams, so that at the end of the day, they solve it again particular process, essentially validate each other. Because it's deterministic, we were talking about earlier, so it's the fact that you're going to arrive at, and then if you're going to arrive at the fact that you're going to assume that the fact is correct. If all is still the same logic with artificial intelligence, can we expect that it doesn't really matter how you develop the algorithms, eventually they'll learn from each other, and then that validation that we may have of the similar system may no longer exist, so we are going to have to come up with a different way of validating the results. How do you see that, that risk in this?
Right, that's, it also reminds me of a joke about superintelligence. Can I say the joke first? Yeah. AI learns, right? It learns to become better. What if it learns to become better and creates a better AI, and that AI creates a better AI and a better AI, and then it falls into the superintelligence loop, and then someday they all become really intelligent and they take over humanity, right? So maybe it wasn't that funny, but it comes back to your, yeah, it sounded better in my head, right? It's an actual thing. The people at Oxford are doing research on this, but anyways. So it comes back to your point on AI, validating AI. I think it's an open research question, but it's not something that's imminent, right? And if you are the developer of the AI and you're aware of the risk, you always have to have that button that shuts down the AI. So that's our way to cutting off the AI before it takes over. I think we can talk more about that offline. Yeah, sure. Sure.
I'm just curious, when you talk about when you create a bot or when you're creating AI, when you're using AI, you're talking about the fact that AI learns from, it depends on the heuristic or the algorithm you have behind it. How do you limit it? What parameters can you put within it so that it doesn't do what you just talked about? Because to me, I'm an old programmer, and I'm trying to understand how you can, I've done heuristics, I'm aware of things that you estimate, right. But when you're creating a bot or when you're using AI, there has to be a parameter in there somewhere that will limit its scope.
Right, so the bot is only the front end to the AI. Conventionally, AI has had different phases, right? Training, and then evaluation, and then deployment, right? And the training is very important because this is the point where your bot can learn bias and other rude comments from Twitter, right? If you have one training phase and then you deploy it and the deployment is just live and hot and working, there is no feedback, there is no loop that just learns in time, right? So you can stop that, and your bot's behavior will only change if the training data changes, right? So this is one way to stop it. You can just deploy an AI that doesn't have this closed learning loop. And this is how conventionally AI was developed. Now, if you want to have real-time learning and relearning from the context where the bot is being used, this is where things like impact assessment and removing bias and removing other problematic part from data before feeding it again into the AI comes into play.
But when you, sorry, I'm just going to follow up. When we talked at the beginning, when you talked about the fact that you could have text recognition and you could analyze text, which is either positive or emotional, whether it's positive, negative, and so on. If you do your AI, you do it, you train it, then you release it, so to speak, you put it out there, and then you said keep learning, but you can also screen what would be good or bad. You have to basically have text. But is that something that you can teach it, or is that something that you algorithmically have to put in those parameters to say anything negative, don't use that as your part of your learning? I don't know if you know what I mean.
Well, maybe it's easier to explain how some companies are doing this. I guess when you used Google, you have seen that more and more they start asking you questions about something. Yeah, you got some kind of result, and then Google asks you, was this useful? Was this information correct? What do you think about this? And you can say yes, no, or even give some small answer. So essentially you need, if you want to keep it learning from the results it produces, you need some kind of collect feedback on the data. And this is typically not, this can sometimes be hard to do. You have to have a way to collect this feedback. We saw an example in the second talk. You can actually do experiments and evaluate the outcome. You can do a crowdsourcing approach and ask people, or have some other way of measuring the results. But this is something you have to put additional thought into. So the first step, you develop this AI and work with it and maintain it. Sort of what you are now talking about, the self-improving, self-learning AI is sort of the next evolution, what people are working on at the moment, but it doesn't come for free. And you have to think about if you want to invest in this, or if some of the simpler solutions don't already give you a benefit right now. It's nice to think about these sci-fi perspectives, bots taking over the world, but from a business perspective, maybe some simple tool that you can deploy next Monday has a more immediate benefit. This is part of the message that we're trying to get across here.
Sorry, I have one final question, given that we've now pivoted into AI ethics and apocalypse and all that fun stuff. Since it is something that comes up in the popular imagination, and the variant on the superhuman joke, such as it was, is that there was this idea of the paperclip problem, right? This is the AI bot that wants to make paperclips very efficiently, keeps doing it, turns humans into paperclips, turns the whole earth into a paperclip. Simple way of illustrating it. Elon Musk has been on about this, and everyone's getting the jitters. You guys are very intelligent and very educated on this subject, far more than I'll ever be. Do you think that passes muster? Do you think that's overstated? Do you think that you are helping evil along?
Does it? Is it gonna make? Well, is it gonna make you feel better if you say we're aware of the misuse of the AI?
No.
I don't know.
Personally, I'm also somewhat of the side of the optimistic approach that we heard earlier, because what interests me is how humans and AI can collaboratively work on a problem together. So the idea that there's huge amounts of data to go through large documents, which is very dull for a human to do, I see this as an opportunity that part of the work, of this dull, monotonous work, can be done by an AI, and the human is freed up to work on the more interesting problems, conclusions, reasoning with support. So this is sort of my personal vision, this interaction that helps humans to deal with complex problems without being overwhelmed by too much data, which humans are not good at.
But given your specific vertical in text recognition, no doubt you're aware of that matter that came up where our constitutional documents, particularly in the United States, were considered hate speech, and they were blocked on Facebook because they use expressions like savages and Indians. And so that requires perhaps a human to put things in context. And I'm not sure if maybe this acceleration we're seeing in identity politics and a reactionary culture might be in part due to lack of context that AI encourages.
Well, yeah, so again, this goes into political and legal discussions, no surprise. Especially again in Europe, where they're discussing upload filters, which this is sort of falls into the same direction, which is somewhat AI related. So yes, no, I don't think somebody has a short answer for this. Maybe we save this for later. But I don't think this should stop you from using a simple tool for solving concrete business problems right now.
There is a project at MIT, I think it's called Moral AI. It's in the context of autonomous vehicles, and there's always this scenario that you have one person versus 5 person, and you're gonna have to hit somebody, right? And how should the vehicle decide? Is it you're gonna go for 1% or 5%? What if that 1% is a CEO, but there are 5 homeless people? What if there are 5 women and one man, right? So they don't have an answer for that. What they did is that they tried to crowdsource the answer. They just gather. You can go online. You can choose. If I were the vehicle, I would hit the CEO. The CEO, not the scientist, right? And they're just trying to figure out, what should we do? What should the AI do? Yeah.
So perhaps as a concluding remark, something that also I hinted at is when you want to deploy an AI, you have to be sure that the problem you want the AI to solve is something you know how to solve. A lot of problems come from people trying to think of this AI can now do a job where they don't know themselves how they would do it. A little bit like the recruiting problem, scanning resumes. So you have to be sure that this is a well-defined problem that you want your AI to solve. Otherwise, it's not going to work.